But this is what it looks like, and I'm going to just start with this, go through some of these steps, and then we'll do the examples. I'll work out the examples. So, as I said before, this is an extension of the last section. We started 2A last week. This is now 2B. So, problem solving with units. One of the strategies that I like to use is when I'm doing problems like this is after I understand what's going on in the problem, I go right to what the answer is asking for. And if I know that I need to end, for example, with milligrams, sometimes I work it backwards and set everything up so that things will cancel. And that helps me work it through forwards. And I'm going to show you. I'm going to try to model that for you as we go. If you're not sure how to start, try that strategy if you're stuck. I find it very helpful when there's a lot of information involved in a problem. And I isolate what I need, and I work it backwards. Another thing to keep in mind, you cannot add or subtract numbers that have different units, meaning you can't add milligrams and inches together, for example. There's no way to do that. But you can multiply and divide them. If you see units that have hyphens between them, for example, the kilowatt hour, you'll see that later on. There'll be a hyphen between it, and that means that the kilowatt was multiplied by the hours. That'll all make more sense when we get to that. But look for a hyphen, and that indicates multiplication. When you see backslashes, oftentimes we just write backslashes like right here. When you see backslashes, that means division happened somewhere. So when you work it backwards, you can kind of undo it and work your way around it that way. Last but not least, it's a very important step, but people tend to gloss over this. Make sure when you're done that your answer is in the units that they're asking for. Oftentimes you're going to be presented with a problem, especially when you're working with medications and things like that. You're going to be given all of this information, and you need to sort through it, and oftentimes you don't need most of it. You might only need one or two pieces of it to answer the question that you're being asked. So make sure you are doing just that and not going too far or answering a different question. Okay, so that's the steps in a nutshell. As I said, I'm going to go through each question on the whiteboard, modeling everything with you so that hopefully by watching me, you'll be able to replicate the way that I do it. So first one starts off real basic and simple. It says you're buying 30 acres of farmland. I just lost my marker here. Okay. You're buying 30 acres of farmland at $12,000 per acre. So what is the total cost? So I'm going to start off slow here, even though I know you all can do this. You're buying 30 acres. It costs $12,000 per acre. That needs division. And then what is the total cost? Okay, let's go to the whiteboard and set this up. All right, so if the question wants total cost, I'm going to work this backwards as I mentioned before and try to model backwards strategy for you, even though I know you know how to do this. If you want cost, that means that you want your answer to end with a dollar sign. And this is the information that we were given that involves money. If that's the case, then the acres need to go. We need to cancel this. So that's my thought process. I want cost. Here's money. That means I got to cancel that somehow. So if I set this up, it's $12,000 per acre means divided by 1 acre. If I set it up like this, and as we talked about before, if acres are diagonally across from each other, they'll cancel. I just need information that has acres in it. And I obviously do right here. So I'm going to put that up here. This will go over 1. That way when I multiply this out, my acres cancel. My answer is left as a cost, and that's what the question asks for. So 12,000 times 30. Let's see, 1, 2, 3, 4 is $360,000 then. There's my cost. Again, it's a very basic question, but the backwards strategy is what I was trying to show you all in that one. Any questions yet?
No.
Okay. Then we're going to slowly move up. Let's do this. Okay. So number 2, you're planning to make pesto. You need to buy basil. At the grocery store, you can buy small containers of basil priced at $2.99 for each 2/3 of an ounce container. At the farmer's market, you can buy basil in bunches of $12 per pound. What's the better deal? So one more time, real quick, I'm going to jot all this information down first, and then we'll work our way through it. So first we've got the grocery store. $2.99 for each, so per 2/3 of an ounce. Okay, then the farmer's market. Is $12 per pound, per 1 pound. And the question wants to know, what is the better deal? So basically, when they ask you that, they're asking for unit prices. The unit price is how much does this cost for 1? So how much would it cost, not for 2/3 of an ounce, but how much would it cost for 1 ounce? And how much would this cost? Well, it's already given as 1 pound. So that is a unit price. The problem is in this case that they don't match. So let me go to the whiteboard and try to explain that a little bit better. Okay, here's the information. They want to know which is the better deal, so they want the unit price. I see a price per 2/3 of an ounce. That's a problem because that's not per 1, that's per a fractional amount. So we're going to have to deal with that. And then the second issue I see is that the ounces don't match with the pounds. The sizes are not the same, so you can't really cost compare these right now. So here's my strategy. I need to know how much does it cost for 1 ounce, and then I need to get the sizes to be the same. To find a unit price, no matter what it's written in, whether it's price per fractional amount or let's say it was $2.99 for 4 ounces, a whole number. To find a unit price, you just divide. So I'm going to divide my cost by my size. I'm going to plug it right into my calculator, and that'll tell me how much it'll cost for 1 ounce then. It's a lot easier to work with than 2/3. So $2.99 divided by, and in my calculator I don't have a fraction key, so I just use my parentheses. If you have that, just plug it in as parentheses. 2 divided by 3, close the parentheses, and that means it's about $4.49 for 1 ounce. $4.49 per ounce. Okay, so far so good?
Yeah.
Okay. I assume silence means everybody's good. All right, so let's look at this one here. This is per ounce. Let's make this one into ounces as well, because I know how many ounces are in a pound. So instead of it being $12 for 1 pound, I'm going to change it to $12 for 16 ounces. Let me see here. If I have, is this on the conversion sheet? Last week, let's see. Yep. So I have a printed copy of this that I'll just show you real quick. If you forgot that or didn't know that, that's a very common weight measurement. It's something you should know if you don't already. But it's right here. 1 pound is 16 ounces, if you didn't know. So that's where I'm getting that from. And there's no conversion to do. It is a conversion. Okay, but now this is now no longer a unit rate. It's $12 for something other than 1. So now I'm going to divide it again, and that'll change it to a unit rate. So 12 divided by 16 is 75 cents. I don't know about you, but when I initially look at these prices, I don't, off the top of my head, I don't really know which one is better because they're totally different. $2.99 for 2/3 of an ounce, $12 for 1 pound. I can't compare that without stopping for a second and having to do math in my head. When I look at these two, holy crap, they're not even close. This is so much cheaper, much, much better deal. Does that make sense to everybody?
Yeah.
Yeah. Okay. So it's important when you're working problems out like this that units match. That's the main goal of that question right here. Make sure you recognize that the units have to be the same if you're going to work with them in any way. Okay. I'm going to pause again real quick. Any questions for that one?
I'm all right.
Okay. Okay, so next one. Your destination is 90 miles away, and your fuel gauge shows that your gas tank is 1/4 full. Your tank holds 12 gallons of gas, and your car averages about 25 miles per gallon. Do you need to stop for gas? First of all, if you're not sure if you need to stop for gas, you should just stop for gas.
I was kind of thinking that too.
Second of all, let's see what happens here. Let's work it out. I'm going to jot it all down. 90 miles is the destination.
I would like not be lucky, like at all. Like I would definitely run out. Like I would have a panic attack. Like
yeah, and it would be in probably one of the worst neighborhoods when it happened.
Oh my gosh.
It happened. I ran out of gas in oh God, it was so long ago. Where was I? I was in New York City, because that's where I'm from. But a little bit past Brooklyn, and I was out of gas, and it was like 3 o'clock in the morning. It was awful. It was awful. So when in doubt, just get the gas.
Yeah. Just pay it.
Let's see. The tank holds 12 gallons. And the car averages 25 miles per gallon. All right. Let's break it down. Okay, so first of all, when I look at all this information, I'm going to try to sort through all of this. To answer this question, I want to know how many miles I can drive. Based on everything that I have here, if I know how many miles I can drive, I can see if I need to stop, because I know I got to go 90. So if I have to go less than that, then or if I can only go less than that, I should say. If I can only go under 90, then I need to stop. If my tank allows me to go, let's say, 120 miles, then, and I only need to go 90 miles, then I've got enough. So I need to know how many miles I can drive. So I'm going to sort through all of this. And if miles is what I want to end with, that means I'm going to have to cancel the gallons somehow. Okay, fine. If I'm going to cancel the gallons, I need to see how much gas I actually have. My tank holds 12, but it's only 1/4 full. So I'm going to multiply it 12 by 1/4 to see how many gallons of gas I actually have. So 12 times 1/4 is 3. Right, and again, you can just plug that in. If you don't know that off the top of your head, just plug it in. 12 times, use parentheses for your fractions if you don't have a fraction key. And just do 1 divided by 4. So I have 3 gallons. We've got 3 gallons of gas. Okay, if I have 3 gallons of gas, now I can use that information to cancel the gallons with the gas mileage, and that'll leave me with an answer in miles. So, just like before, I'm going to take the amount that I'm starting with and put it over 1 and multiply by my gas mileage as if it was a conversion. So the gallons are going to go down here in the bottom. The miles are going to go up here. And that way the gallons will cancel like I need them to. The 25 miles per gallon means 25 per 1. So this is a 1. And I'm going to take it straight across. When I do that, my gallons will cancel. And 3 times 25 is 75. 1 times 1 is just 1. So, I mean, I'll write it out. But the point is, we can go 75 miles. Okay, so if we can only go 75 miles, but we have to go 90 to reach our destination, then obviously we have to stop for gas. How'd that go? Is that making sense?
Yes.
Okay, is the strategy that I'm trying to, well, I'm beginning to present, I'm going to use it even heavier in the next couple of problems, but is the strategy by figuring out what I need and then working backwards to cancel the stuff attached to it, is that helping at all?
Yeah, it's just like a newer like method. Like I don't think I've ever really like worked a problem like that.
Okay.
Like I don't know. I'm used to like doing like proportions, but I feel like honestly if I was to like do that like on my own, like I might need to stare at it for a second. Like in all complete like honesty. Like I probably wouldn't have like really like thought of how to do it your way.
Mm-hmm. Yep.
So I don't know. But it made sense how you like presented it.
Okay. You don't have to do it my way. If you can think through it and do it in a different way, that's totally fine. The reason I'm presenting it to you is because there's going to be a lot of questions as we get further into this section that are a little bit more obscure. And just identifying what you need and working it backwards allows you to solve it without actually really needing to know all of the technical information that will be presented in the problem. Mm-hmm. So I find that helpful in questions like that. That's just me. So, all right, so since you said that, we're going to do another one. Let's see. I'm going to pick out this one right here. These are extra practice. So let's do one like this before we move on to the next part. So let's see. We can rent a storage locker for $32 per square yard per month Or we can rent one for $2 per square foot per week. Okay, and which one's the better deal? Assume 30 days in a month. Okay, so kind of like the other problem, they're asking for a unit price in a way. So let's see what we can do here. All right, first I'm gonna identify some stuff that I see. I got dollars and dollars. Okay, that's good. Here I've got cubic yards and, square yards and square feet. That's a problem. Those need to match. And then over here I've got months and weeks, and those don't match either. So we're gonna have to convert to 1 unit of time as well. So let's start with this. This is $32 per 1 square yard, and this is $2 per 1 square foot. We need these to be the same. So we're going to either need to do, we're not going to do them both, but we're going to pick one of this. We're going to either need to change our square yards to square feet, like this, or we need to change our square feet to square yards. One or the other, but they have to match. So in order for me to decide what I would rather do, I'm going to go and look up the conversion from last week and see what I can find. Where did I put that? Here we go. Okay, so here is the conversion pages. And then can we see this? Is it going to adjust for me? Let me pull it up in the actual Word document. It'll be easier to just go this way. Okay, so this is the one from last week that we were looking at. So remember, we're looking for square yards and square feet. Let's see here. Anything on here? You see cubic feet and cubic yards, but that's not what we want. This might not even have it, which means we're going to have to find it ourselves, and that's fine. I thought it did though. Well, I guess not. All right, so we're back to, we're going to do even more work now. Let's back up even further. Go over here. You don't have it, so we're going to find it ourselves. Do we know how many feet are in 1 yard? Anyone?
Oh, isn't it 3?
3, yep.
Okay.
There's 3 feet in a yard. You're talking about regular feet or regular yards, nothing squared. But since we need it to be squared, I am going to square both of them. So that means 1 yard times 1 yard, which is just 1 for that one. And fix that. 1 square yard. And then this one here is 3 times 3, which is 9. So 9 feet squared. If I went the other way, which now that I'm looking at all of this, this is probably not even necessary. If I went the other way, I would have to divide, and that would give me 1/3 instead. And I don't want to deal with fractions if I don't have to. I would rather stick with whole number like 1 and 9. So I'm going to go right with this one. And I'm going to fill this in. And this is what I need right here. So let's get rid of this. Let's ignore that. Okay, so now let me recap everything that we've been trying to do here. The money matched to begin with. This square yard did not match with this square foot, but now it does. So what I'm going to do right now, stay with me, is change it. 1 square yard is the same thing as 9 square feet. You with me now?
Yep.
Okay. At least I've got the same unit, but I now have another problem. I don't have a unit price anymore, and that's what we need. So my last step for this, and then we'll deal with the time, is I'm going to divide this just like the Basel question. I'm going to divide this and change it to a unit rate. So $32 divided by 9 is about $3.56. So it's no longer 32 per 9, it's now $3.56 for 1 square foot. Now we're closer. It looks a lot better. We've got $2 per square foot, $3.50 per square foot, and now the times don't match. So let's deal with that. Okay. Is it easier to change months? It's per 1. Would it be easier to change 1 month to a number of weeks, or change weeks to months, you think?
Week to month.
Okay, so how many months? Like this? You want to do that one? How many months are in a week?
Oh.
You see what I mean?
Ah, buddy. Woo. All right.
We'd be
definitely the other one.
Let's not do that one.
Yeah, no.
Okay, on average, how many weeks are in a month?
Isn't it like 4?
Yeah. It's actually 4.3, but we're going to use 4 because it had told us in the problem that we could assume there's 30 days in a month. So 4 weeks in a month is pretty close. All right, so that means, let's go back one more time. We got $3.56 per square foot per 4 weeks. We need this to be 1, so we've got to divide it. So it's going to be $3.56 divided by 4. Let me write it over here. $3.56 per square foot per 4 weeks. Move this over. You can see what I'm doing. I'm changing this to a unit rate again. This time I'm keeping these two attached as one thing and dividing 356 divided by the 4 so that I get a price per 1 instead. And that brings me to 89 cents per square foot per week. So we got 89 cents per square foot per week, or $2 per square foot per week. Which one's better?
Sorry, I'm still catching up.
Okay, that's okay. Here's our choices.
Well, the 89 cents per week is definitely, obviously better.
Yep. Obviously better once you get it to comparing apples to apples. That's the whole key to these better deal problems. It started off so obscure, you can't really even compare. And I'm willing to bet that most people just off the street, if they looked at these two prices, would want to go with the $2 because $2 seems so much cheaper than $32. But when you look at all the fine print, we were talking about $32 per square yard, which is a larger space, and it's per month, versus this is $2 per square foot, which is a smaller overall, and it's for less time originally, the way that they wrote it out. All right, so let me recap this type of a problem. Compare unit to unit. Dollars matched, good. Size, didn't match, we converted. Time, didn't match, we converted. And then anytime you need to compare, you divide until you get a unit rate. So something per one per one. Something per one per one. Just keep dividing. Okay, any questions?
Nope, I'm okay.
Okay. Anybody else? Okay. Let's keep going. All right. So here now is what I was talking about with hyphenated units. They're going to come into play right now. This is a topic that is unfamiliar to a lot of students because they're just not used to seeing things like this. A lot of the stuff that we've done prior to all of this is familiar in one way or another, whether you go shopping or you cook, something like that. But now, when you talking about power and energy, people really start to panic because they're not familiar with it. It's done the exact same way. So if you could follow along with what I've been doing so far, even if you couldn't do it independently just yet, the more you practice it, you'll start to get better. If you can follow along with what we've been doing, you should be able to do this no problem. So let's talk about what you're going to be looking at for these problems. The watt is what you're going to be working with primarily, because that's a measurement of power, but it is a metric unit. So I'm going to jot it down up here when I pull the whiteboard back up. The watt is metric. So when we talked about the metric prefix line last week, we're now going to bring that back up in here, and the base unit is now going to become the watt. So we were looking at it last week in meter and gram and liters. Now it's just going to become the watt, but everything else is the same, the way that you convert. So here is an example of a hyphenated unit. Kilowatt hour means some measurement of kilowatts got multiplied together with some measurement of hours and created a kilowatt hour. And that'll make, again, it'll probably hopefully make more sense as we go through the problem. So just keep it in mind, when you see a hyphen, something got multiplied. So here we go. A utility company charges 15 cents per kilowatt hour. Right off the bat, I don't like to use the penny sign. I'm going to make it 15 cents using the dollar sign. So I'm going to do 0.15 with a dollar sign in front of it when I do this, because nobody uses pennies anymore. Okay, so 15 cents per kilowatt hour of electric. And then the question wants to know, how much does it cost for a 100-watt light bulb and for a week? Okay, let's go to the board and let's break this all down. So I wrote it down. They gave us 15 cents per kilowatt hour. They gave us a 100-watt light bulb, and we're leaving it on for 1 full week. The question wants to know, what's it going to cost? So I'm going to try to bring this strategy back in here. I'm going to work through this with you. If you have no idea how to start this, go to the question, find the information that has cost associated with it. This is what they want in the question, and this is what we're going to have to end with. Right? So this is what we need to answer the question. In order to get something that is in a money amount, this thing here that's attached to it is going to have to cancel. And it's per kilowatt, so that's per one, by the way, so let me add that in. We're going to have to cancel this out somehow so that we're left with just an amount of money. Okay, so that's my strategy. I need to cancel the kilowatt hours. If I need to cancel kilowatt hours, I need kilowatts, and I need hours. Okay, so let's see what I got. I got watts, not kilowatts, but at least it's something I could work with. That could get me the kilowatts. And then I also need hours. I need both of these things if I want to get this by itself. So I need hours. I've got 1 week. At least that's time. That can get me hours. So I'm going to do this piece by piece. First, I'm going to convert the watts to kilowatts. Then I'm going to convert my weeks to hours. And then at the end, I'm going to put them together. Because if I multiply them together, I'll create kilowatt hyphen hours. Does the strategy make sense so far?
Yep.
Okay. All right, so here we go. Let's start with the watts. I need to convert watts to kilowatts. Watts is metric, so I'm gonna bring in my metric prefix line knowledge. Here we go. Here's kilo, hecto, deca, base units, now the watt. Deci, centi, milli. I'm starting at the watt, and I want to go to kilowatt. So I need to go to the left 3 spaces. Starting at the back, I'm going to go left 1, 2, 3, and now it's in front of the 1. There we go. Now I've got kilowatts. Everybody okay with that?
Yes.
All right. Let's go back over here then. So I got kilowatts. Check that off. Now I need hours. All right. If you don't know how many hours are in a week, we're going to just set this up and string this all along, multiply it all up. So we're starting with 1 week. I'm going to put it over 1. I'm going to put week down here. And if you don't know how many hours are in a week, you can just go to days first. And then from there, I could take another one, string it on, put days across so that they'll cancel. And I know how many hours are in a day. And that'll give you what I need. So there's obviously 7 days in a week and 24 hours in a day. And then I can take this straight across, which will cancel out the weeks because they're diagonal, and cancel out my days, which will give me hours. So how many hours is this altogether?
I got 168.
That's right. And now you know, 168 hours in 1 week. Okay, So let's go back here now. Got hours, got kilowatts. I need to make this kilowatt hours. So kilowatts times hours will give us something in kilowatt hours. That's not a minus sign, that's a hyphen. So we had 0.1 kilowatts times 168 hours. And that makes 16.8 kilowatt hours. All right, now we have the unit that we were trying to get to. So take it all the way back over here where we first started, because we need kilowatt hours to cancel this right here and be left with money. Okay, I need more space. I gotta erase some stuff. There's a lot of writing. So let's now go back. I have what I need. I've got 15 cents per kilowatt hour. That was given information. Now I just created, based on the other information that they gave us, I just created a kilowatt hour. So I'm just going to put this over 1 so that those are diagonal, and then they'll cancel. So when I take it straight across, those are now gone. I'm going to multiply that last bit. And I got $2.52. Thank you. Thanks, Pumpkin. You washed it. Thank you so much. All right, so it's going to cost us $2.52 to run this 100-watt light bulb for 1 week. Here's my answer. Any questions before I look at the next part? There's another part to this question.
No.
All right. Okay. So they want to know then, how much would you save in a year if you replace this bulb with an LED bulb that provides the same amount of light, but it only runs on 25 watts of power? All right. This is a real life situation that if you haven't considered it yet, after I show you what the savings is, you might want to go out and buy yourself some LED bulbs. All right. So
excited to grow up.
Yay for adulting. All right, so I'm going to write it down here. Part B, we're talking about 1 year now. Keep that in mind, not a week. It's a year, and it's 25 watts. And they want to know what the savings is. Okay, let's take a look. Now, since we've already done some heavy lifting from the other question, we won't have to do all of this all over again. So let's go back here. Just bear with me for 1 second. In the previous problem, we started out with 100 watts, and it became 0.1 kilowatts. So now we have 25 watts instead. Just move that back 3 times. That changes it to 0.025 kilowatts then. We don't have to do the whole process all over again. We already thought it through. We moved it back 3 times. So we're going to do the same thing right here. Make sense?
Yep.
Okay. Next thing. You got the answer, Eddie. Okay, go, 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 go. Sorry, the kids are. Hang on 1 second.
They sound so cute.
They're cute this week. Last week they were awful. I played back the recording and all I can hear was them screaming. Oh my gosh, I'm gonna have to edit this out. Okay. Where were we? Okay, so in order to price compare this and to save us a little bit of work, I'm not gonna go through the year just yet. I'm just gonna figure out what would it cost to run a 25 watt bulb for 1 week, and then we could figure out the savings per week, and then we can change it to a yearly amount. So again, bear with me here. I'm going to go with 1 week because we know how long that was. It was 168 hours. And that way I don't have to go back and repeat my calculations too much. So I'm going to take my 0.25 or 0.025 kilowatts, multiply that by my 168 hours, and that'll change it to kilowatt hours. 0.025 times 168 is 4.2. So 4.2 kilowatt hours. All right. And now I'm going to multiply the 4.2 times the cost from the last part, the 15 cents, just like we did in part A. It was 15 cents per kilowatt hour, which is what the company charges. And now it's not 16.8 kilowatts, it's now only 4.2. And then that'll give me the cost to run this LED bulb. So let's see, 4.2 times 15 cents. It only costs 63 cents then per week. All right, so going back, it was $2.52 for the old bulb, only 63 cents for this new LED bulb, but that's per week. And it's also not actually answering the question they wanted. They wanted to know the savings. So to find the savings, let's subtract them. So 252 minus 63 cents is a savings of, I got $1.89. That's still per week. And now, if I want to know how much that would be for a year, how many weeks are in a year?
54?
54?
Okay. Jeez.
Take $1.89 and multiply it by 52. And that is $98.28. That's the savings per year. So now here's what I want you to think about. Maybe that doesn't seem like a lot of money to you when you think about it over the course of a year. But this is just one light bulb. Imagine if you replaced all of your light bulbs. And not only that, but you're going to save this every year. And LEDs last longer, so you won't have to replace them as often, which is also an added savings. The only issue with LEDs when you first start out is they cost more to begin with. So an LED bulb might cost you 20 bucks, so you're really only saving $78, but that's for the first year. It'll pay for itself after that. And then some. You'll be making tons of money just by replacing your old stuff with new energy efficient stuff. And then on top of that, more adulting, side note, you could get a tax credit if you buy certain things that are energy efficient. And that saves you even more money. So just stuff to think about. Real cost savings here. All right. How did we feel about that whole thing? Do we need to do another one, or can we keep going?
It's a lot.
That is a lot.
But at least on my behalf, I think I'm okay.
Okay. All right. I'm gonna assume these other guys are not answering me, so hopefully they're okay. Mimsy, Tanaja, if you've got questions, make sure you ask me.
Okay. I'm learning. It's better for me to learn in person than over Skype.
It's hard. Is that what you said?
Yeah, I'm not gonna understand it like as well as anybody else. Like I have to be like verbally face to face to learn it.
I understand. I'm hoping that with the videos and stuff that we've got here, if you guys are really struggling, watch them a couple times and hope maybe the repetition and working out with me when you've got some extra time, because I know I'm moving fast through this whole thing, but that would be my best suggestion, because I agree with you. This is not ideal. This is not how I would want to take a math class either, personally. But watch the videos, go through the homework, use the tutorial tools if you can. Tanaja, I know you're one of the ones that are having difficulty getting onto my math lab, but once you get up and running, there are some tools that will help you with that too, I'm hoping.
Okay, because I suck at math.
Beyond that, I don't know. Are you still not able to get into my math lab yet?
No, I just submitted in homework 1 an hour before class started.
Okay. Did you have to do that on your phone?
No, I actually received the computer.
Okay. Okay, good. So, moving forward, this is for everybody. I have set office hours on Tuesdays, but if you're available, let's say like on a Wednesday in the afternoon and I don't have a class, we can Skype one-on-one too, if that would help you. So just let me know. That's something that's available to you also.
Okay.
All right. If there's nothing else, I'm going to keep going because we're on the last part. So that way you guys can get a little bit of a break too. I know this is a lot. This is a real heavy section. That's why I only do this one day. So let's go to this last part here. Okay. What kind of majors do I have here? What programs are we in? Is it medical assisting, nursing, business?
I'm in medical assisting.
Okay. What was that, Nimsy?
I'm in medical assisting.
Okay. What are you in, Tanaja? What program?
MA.
Oh, good. Okay, all three of you are in the same thing. All right, well then here is your section. This is your wheelhouse right here. What we're going to talk about now is units of concentration, and basically what this means is how do you use all of this to work out dosage problems and things like that. So to put it into context that's more familiar, maybe this will help click also. Here's an example. A child weighing 15 kilograms has a bacterial ear infection. A physician orders treatment with amoxicillin at a dosage based on 30 milligrams per kilogram of body weight per day, divided into doses every 12 hours. All right, so definitely going to jot all this down. We got a 15 kilogram child. Dosage is 30 milligrams per kilogram per day. And that's divided into doses every 12 hours. All right. The question wants to know how much amoxicillin should the child be prescribed every 12 hours? Okay. No matter what I do, I always start off wrong. All right. Here's all the information. I jotted it down. Let's break it down. So let's first go to what the question wants. If they want to know how much amoxicillin we're going to give, and the dosage of the amoxicillin is 30 milligrams per kilogram per day, they want to know how many milligrams every 12 hours. So we need to end in milligrams if that's what they're asking for. We also got to keep in mind that they're asking for every 12 hours, so they want to know how many milligrams per dose, in other words. If it's given every 12 hours and they're asking for it every 12 hours, they want to know how much we're going to give per dose. Make sense? Hopefully. Okay, your silence is telling me we're okay so far. So now
I just realized I was talking with my mic off. I'm good.
okay. Okay, so let's see. If we need milligrams per dose, we need something to end in milligrams. Here's the information for the milligrams. That means we're going to have to get rid of the kilograms that are attached. And we're going to have to get rid of the days. So let's see what we can do here. Let's start with the fact that it says 30 milligrams per kilogram. So that's per 1 kilogram. I will count for the fact that this is per day when we're done here. I don't want to involve the per day necessarily in my calculations. I'm just going to leave it off to the side. So it's kilograms per day. I'm going to attach it like that. Okay, now I need this to be milligrams. I'm going to have to cancel the kilograms with something. In order to do that, kilograms has to come up here. Let's see what I got. I got the child's weight. So 15 kilograms can go over 1 so that the kilograms will cancel, and I'll be left with some kind of answer that'll be in milligrams per day. You with me so far? Hopefully. Okay. So I'm just going to multiply this out. 30 times 15 is 450. 1 times 1 is just 1, so it's 450 milligrams per day. Okay, fine. Let's look. Did I answer the question? I got milligrams per day. Is that what they wanted?
Nope.
Nope. So let's go back and figure out, if we're giving it every 12 hours, how many times a day would that be?
2.
2. So I'm going to take this answer that I got here, milligrams, per day. I'm going to multiply it by the doses. So sorry, I'm going to divide it. What am I doing? So that will give me 225. Okay, there's my answer. That's what they asked for. That's what I've got. I know I'm good.
I'm all right.
Okay. Here's a part B. Let's talk about it. If the medicine is to be taken in a liquid suspension with concentration of 25 milligrams per milliliter, how much should the child take every 12 hours? All right, now let's go back here. I'm going to write down the information that we got from part A real quick. We got 225 milligrams per dose. And now it's telling us we've got a concentration of 25 milligrams per milliliter. Basically what this means is, since it's for a child, the milligrams is the amount of medication. They're going to mix it up in a liquid form, like that pink stuff if you guys have kids, that pink amoxicillin. They mix it in with that so that the child can drink it, because most children can't swallow pills. And what they want to know is, how much should we now give to the child? How many milliliters should be taken then, in order to get the right amount of medicine? It's all mixed up in there. All right, so let's go back here. All right, so if I want milliliters, that's what the question wants. Here's the information in milliliters. I need that isolated. I need that by itself. That means I'm going to have to cancel out the milligrams. And I've got milligrams up here from part A, because I know that's how many per dose. Actually, I should add that on. How many milliliters? It said every 12 hours, so per dose. And that's why I'm going to work with the information we got before. I'm not going to go back to the information per day, because I need it per dose to answer the question. Okay, so here's how I would start it then. If I need to end in milliliters, then I need milliliters to be in the top, and I need to cancel milligrams. So this is how I would set it up. You could do this in a couple different ways. This is just what comes to my mind. I need milliliters to be in the top, so that's left in my answer, and I need milligrams to cancel. And based on what I'm given here, I'm going to take the 225 per dose and use that first, and then I'm going to flip this one upside down so that these two will cancel, and I'll be left with milliliters per dose. Does that make sense?
Yes.
Okay. You can manipulate all of this pretty much however you want, as long as it's coming out as what you need it to be. So you can flip the concentration information upside down if you need to, depending on what you're trying to do. And then we're going to multiply it straight across. It's going to be 225 times 1, which is just 225, and 1 times 25. This is going to be milliliters now per dose, and that tells me right there at the end, I'm just going to have to divide that through. 225 divided by 25 is 9. Any questions about that one?
No.
Okay. Let's see here. So what's left?
Actually, I do have a question now that I'm thinking about it.
Yep.
So for that, like, okay, so like at least like going for part A, I don't mean to backtrack,
Yep.
but since it was for every 12 hours, obviously like we got 2. So we don't need to do anything with that, right?
We got
So
2.
it has to be twice daily.
Yeah, yep.
Okay, so you don't need to do like anything with like at least the time part.
No, the time tells you how many doses you need.
Okay.
And that's why it's there. So if it's every 12 hours, that's 2 times a day.
Mm-hmm.
Whoops. Keep doing that. Sorry. So every 12 hours would be 2 doses. It could be every 6 hours or every 8 hours. All based on 24 hours. So 24 divided by 8 means that would be 3 doses. Every 6 hours would be 24 divided by 6. That would be 4 doses a day.
Okay.
And so on. So I didn't write that out, but yeah, that's where the 2 came from. Because you gave me the 2, I kind of figured you
Right.
must have been what you did.
Right. I just wanted to make sure because I didn't know if it was like, you know what I mean? Like if we had to do like an extra step for that or whatnot, or if it just already like, you know, made its way into the question.
No, I think they're putting information like that in there to try to trick you to see if people are going to use 12 instead of 2.
Okay.
Other times you're going to see it literally written out like this. And if you know what that means, do you know what BID means?
Yeah.
Then there's nothing to do. So they wrote it
Okay.
that way. It's more likely going to be BID because that's what medical professionals use. They're not going to write all that out. They're going to put BID. But they're putting that in your math problem to try to trick you. So just make sure you're aware
Got it.
to use the 2. All right. Anything else? I think we'll do one more. Make sure that this is pretty good, and then I think we're going to call it quits after that. So here's another one. Let's see. Do I want to do that one? Let's do this one. This one we really haven't talked about this. This has got drops. All right, let me erase this. All right, so a normal saline solution, which is 0.9 milligrams of sodium chloride per 100 milliliters of solution, is given intravenously, and a total of 0.5 liters of the solution is given over a 4-hour period. Part A, what is the flow rate in units of milliliters per hour? So I'm going to jot it down. 0.9 milligrams per divided by 100 milliliters. And then we have a total of 0.5 liters, half of a liter, and that's given over 4 hours. And we want the flow rate in milliliters per hour for part A. Okay. Let's see if I get it this time. Oh, pretty close. All right. Here's all the information. Let's see what we've got. Some people overthink this first part. We just need to divide milliliters by hours. So let's go back and look and see what we got for milliliters. Here I see milliliters, but attached to that is milligrams. So if I need it to be milliliters per hour, I'm going to have to get rid of the milligrams. I don't have anything in the rest of the information here. I don't have anything in milligrams. So I can't cancel that, which means I can't use this one. Let's see what else we've got. We've got liters. meters could be used to create milliliters if I convert it. And then I have hours. So that matches. I'll use that too. So here's what I'm going to do. I'm just going to convert my half of a liter to its milliliters. And that'll tell me if I divide that by the hours, that'll tell me the flow rate of all of this in milliliters per hour. All right, so if I'm going from liter to milliliter, that's metric. And liter is the base unit. And I am starting with liter, I'm going 2 milliliter. So 1, 2, 3 to the right. Basically, we're multiplying by 10 3 times, or 1,000, because there's 1,000 milliliters in a liter. Any way of thinking about it. So here we go. 0.5, move it over 3 times. 1, 2, 3. Makes it 500. Okay, so for a flow rate, it would be 500 milliliters given over 4 hours. And if I divide it through, it's basically creating a unit rate like the better deal type of questions. 500 divided by 4 would give me a unit rate of 125 milliliters per hour, per 1 hour. So there's part A. Any questions about that one?
That's good.
Okay. So let's see what they want next. What's the flow rate in units of milligrams per hour? Okay, so now we're going to involve the milligrams back up here from the concentration that we were given over here. This is the only milligram information we know. So we need milligrams to be isolated per hour, which means we're going to get rid of the milliliters now. The easiest thing to do, since we already know the flow rate right here, is to just use this and bring the milligrams into it. So it's going to be 0.9 milligrams over the 100 milliliters. That was the concentration that was given to us. And we're going to multiply that by the 125 milliliters per hour that we got from part A. Because it's the fastest and easiest thing to do. That'll cancel the milliliters out, and we'll be left with milligrams per hour then. So let's multiply it straight across. It's going to be 0.9 times 125. That gave me 112.5. 100 times 1 is just 100. And then I'm going to divide this through. 112.5 divided by 100 is 1.125. And now it's in milligrams per hour. And careful, you mentioned this before, Jessica. Watch how they want you to round answers like this. This might be one where they're asking you for tenths or hundredths or something like that. And if you give the full exact answer, they'll mark it wrong. So watch for that. All right. I think there's one more part. Let me see. Yep. So let's talk about this. This is involving drops now. So if each milliliter contains 20 drops, which is GTT, what's the flow rate in drops per hour? All right, let's Let me go over here. Now we've got 20 drops per milliliter. And they want drops per hour. Okay, and add it all the way up here. Why is this so crooked? There we go. Okay. All right. Kind of like part B, we're going to just bring this in with us and use the flow rate that we got in part A and cancel out the milliliters, and that'll give us drops per hour. So starting with, start with either one. If we just start with the 20 drops per milliliter, that'll put drops in the top, and then we can cancel out using the flow rate from part A. We can cancel out the milliliters right here, and then we'll have drops over hours. We'll have drops per hour as an answer. So taking it straight across, the milliliters are gone. And 20 times 125 is 2,500 drops. 1 times 1 is just 1, so drops per 1 hour, drops per hour. All right, that's the last part of the last problem for this section. First of all, are there any questions about that particular problem?
Nope.
Okay. So then the second point I want to make to wrap this whole section up, there are going to be problems that are going to, like this, that are going to give you all kinds of different information. You might not know exactly how to sort through it all, but as you go through not just this class, but other classes, you'll start to be able to read these a little bit more. You'll know which pieces of information you need, which ones you can discard, depending on what the question is asking. Some of it might be used for a later part, like what happened down here in part B, in part C. You'll start to get more comfortable with that if you're not already. The best advice I can give you in order to become more comfortable and not just get lost in all of this is to try to replicate some of the things I was doing with canceling and working things backwards. Try it when you're doing it at home. See if it helps. And I promise you, the more you practice that, the whole canceling thing and setting things up like this so that they're diagonal and you have what you need on the top and what you want to end with on the bottom, you'll start to understand the whole strategy a lot more clear as you practice it more. So that's my little spiel. Let me go real quick back to Blackboard before you guys go and just show you what we got going on here. So if you didn't complete the homework that was due today, it's still going to be extended for an additional week to give you some extra time just to get up and running. If you did complete it, there's more. There's new stuff. So if you click on the My Math Lab tab and go to your course home, let's see if it should be open. I'm going to make sure right now. Okay, yep, it's showing up. Here's homework 1, and now homework 2 is going to show up, but the quiz is not showing up. So make sure you click on View All Assignments if you see what I see, and then hopefully it all comes up. So it is not coming up. I'm going to have to fix that. I'll do that right after we're done.
Yeah, I was just about to tell you, the thing keeps saying past date.
Okay, I got to fix the date then. So yeah, that's from last semester. So homework 2 is definitely open. I'll fix quiz 1 right now. and then you'll see it in your list. I'm going to take all these other ones off.
When do you want the quiz turned in by?
It's going to be the same date. It's going to be next week.
Okay.
And you'll get an additional week after that too. But for this week, also heads up, make sure you are working on the homework and the quiz by next week, because if you don't, you won't get the practice in that you need for the thing that's coming next. That's where I'm going to go after this. Go back to...
So that quiz 1 that's due on the 11th, that's like the real thing, right?
Yeah, but it's just a quiz. It's short.
Okay.
Not... You're going to have an...
And we don't have a limited tries on the quiz? Or
You
we
do. You do.
Okay.
You have a separate exam next week that you guys have to do in a little window of time during class time. If you're not able to log in, if you're having any kind of issues, you need to email me as soon as possible next week to let me know so that I can schedule you for a different time slot. Because the exams have to be taken during class, whereas the homework and the quizzes are both basically like homework. You just do it. You have a full week to do it. You have unlimited attempts at homework and unlimited attempts at quizzes. The quizzes they're just a way to kind of get you ready to take the exam that you'll have next week. So let me before I get too far ahead of myself, let me go back all the way back to our Blackboard class and talk about that.
Ms. Walker, can I ask you a non-related question to Math Lab?
Of course.
Okay, I see that. Okay, so I'm from the Parma campus, and I see that you're from Akron, based off like your thing.
Yeah.
Like, is this just going to be like an online class for like the rest of the semester, or like, how does that work? Like, do you come to Parma, or am I gonna have to come to you?
No, we're online for the rest of the semester.
Okay, I just wanted to make sure about that because they did not put that in the description.
We can
Just wanted to make sure.
This is all because of COVID. It was not supposed to be that way, but because we started with remote, they decided that they wanted to just
Okay.
in a whole semester remotely because they didn't want students to get confused and all of that, which everybody still is. You're not the only one.
Right. I just was like noticing that. I was like, because I don't know. I haven't seen you like around the campus, so I kind of figured like you weren't from ours, but I just wasn't sure like because they never said that it was like, online. Like I figured it was because of COVID, but like I don't know. I kind of figured we had like an actual class, so that's kind of good to know.
Here's the thing. So this is supposed to be. This is like I don't know how to describe this. We're not really online, but we're not really face-to-face right now. That's why we're calling it remote. There is a section of 201, which is online, and it's totally different. It's like 7.5 weeks long. You are on your own. There's no Skype calls. There's just you doing my math lab and reading PowerPoints and notes. It's pretty rough, in my opinion. Since we were supposed to be face-to-face, we are the full 15-week semester, and we're replacing the face-to-face with these Skype calls and the more interactive type of a format. Good night.
I hate to interrupt,
Got it.
but are we allowed to hang up, or do you want us to stay on?
I want to show you one more thing real quick before you go.
Okay.
So just hang on 1 second. So going back to this, go down here to our tracking calendar. If we were face-to-face, Jessica, I'd be coming to the Parma campus, which I do. I teach half at Parma and half at Akron. I'm just listed.
Oh, okay.
I'm listed at Akron because that's where I was hired on.
Got it.
Okay, so here we are. Here's week 3. This is the section we just did. These are your 2 new assignments that will be posted in my math lab, both due next week. And then underneath here, see how it says Review Exam 1 and Study? Here is what I have for you to help you with that. Beyond the homework and the quiz, which should help, in Blackboard under Content. I'm going to have to unlock this too. In week 3, it will be in week 3, I will have an exam review for you guys. And this is what it looks like.
We don't do projects or nothing in this class, do we?
We do. We have a project, but it's later. We'll talk about that later on in a few more weeks.
Do you post it in the same spot where we find homework and quizzes?
It'll be in content.
Okay.
It's a PowerPoint that we're gonna make. We're gonna do it over several weeks. It's gonna take us. We're gonna work on it like 8 weeks. There'll be different parts and different check-in spots too for you guys to submit some stuff before you have to. You're not gonna just be on your own to do one full project and then turn it in. So there'll be parts, and we'll assemble it at the end. This is the exam review. It's basically, this is your exam. Word for word, question for question, in paper form. If you want to practice this, if you have a printer, you can print it. If not, you can just work the problems out. This is exactly what your exam will look like, word for word. And then at the end, there's a conversion table too, which is another thing. I will give this to you to use. And at the end, you can check. I give you an answer key at the back. Beyond this, if just checking your answers doesn't help you figure out what you got right and what you got wrong, go back here in Blackboard. I will also post an answer key with the fully worked out solutions and how I got them. So here's my work. So you can see exactly what I did to get the answers from the answer key. All right, so this is your study guide. Everything that we did in class, your homework and your quizzes should help you prepare. And then this is going to be word for word what your exam looks like. The only thing I'm changing is the numbers. So instead of it being 903 employees and 751, it'll be 820 and something else. It'll be the same question. All right. So now I'm done. Do you guys have any questions for me before we end?
No, I'm done. Thank you.
Okay. All right. I'm gonna turn my screen off, and if you guys are good, I'm gonna stop the recording, and I'm gonna get all this stuff posted for you, and I will see you here next week.
Thank you. Have a good
bye.
Bye.